This is a demonstration of hardware acceleration using an FPGA. What we're looking at right now is an implementation of the Lattice-Boltzmann algorithm implemented on the ARM A9 that's inside of the DE1-SoC development board, which also includes a Cyclone 5 FPGA. So this implementation of the Lattice-Boltzmann algorithm is implemented entirely in C and is running on the ARM as opposed to the FPGA. What I'm about to do is, after we watch this for a little bit to get a sense of the speed with which this is being animated, I'm going to program the device with a different program that implements the Lattice-Boltzmann algorithm entirely in Verilog, and we should see a considerable speed up. So what we're seeing, incidentally, is fluid flowing left to right through a 32 pixel wide and 512 pixel, 32 pixel tall and 512 pixel wide lattice. The fluid is flowing left to right over a linear barrier, and as it flows, it's generating a vortex sheet behind it. So I started this program about when I started talking, and you can see that at this point now, the vortex sheet is pretty much fully formed. So what I'm going to do now is reprogram the device with a different program, which, as I said, implements the Lattice-Boltzmann algorithm entirely in Verilog. And the colorization scheme is a bit different. Let me just restart it again. But you can see that this is animating about 200 times faster. Just to put some metrics on this, the C implementation that we just looked at, each frame updated in about 18.2-ish milliseconds. And in the parallelized Verilog implementation, these frames are updating at about, we're seeing about one frame update every 0.087 milliseconds, or every 87 nanoseconds. So it's about a 200 times increase or so. And it's worth mentioning that it actually sort of looks like the vortex sheet is moving backwards in this, but that's only because the speed with which the vortices are being animated to the right is actually aliasing with the 60 Hertz update rate of the VGA display.